what we're gunning for with this podcast, I would say, is we're really just trying to do like the Joe Rogan experience, but like way cooler.
Yeah, I'm gunning for his spot.
You're gunning for like a multi-million-dollar Spotify deal?
Yeah.
Okay. And welcome back, everyone, to the Joe Rogan Experience Jr., the JREJ, the Dredge.
It is kind of weird, right? That we've never seen inside the moon.
Chompy, pull up a video. I saw a video recently, Chompy. Chompy, pull up this video. It's like people.
It's crazy. It's
you're not
honestly
even gonna believe it.
honestly
Did you know
crazy.
monkeys only use 1% of their brain?
Did you know that evolutionarily speaking, chimpanzees went a different way with their genitalia? Wait, I'm telling you now. Wait.
I heard.
I'm actually telling you.
Okay.
No, like out of character. I'm telling you.
What are you telling me?
Chimps went a different way with their genitalia.
What do you mean went a different way?
So you know how like humans,
like a choice, like they're like, I think I'm gonna go a different way on this one.
Yeah, they took notes. You know, like how human males have like a proportionately sized wang to their testicles.
Is that true?
Well, I mean, it's a chimp's wang is super tiny, but they ejaculate in an incredible amount.
Is that why that's what you meant by they went a different way?
Yeah, so it's
what? And pardon me,
think about it. No, so like evolutionarily, human males have a longer wang. Or
just say penis.
A larger dongler to make it more likely that their sex cells
that's going in.
Yes,
and get the job done.
I understand what sex is like.
So do you? Chimpanzees
went a different way.
Way with it. They have a much smaller, so they're not relying on the geometry of the dongler.
On this next iteration of natural selection, let's go a different way.
So to make up for this, the geometry of the dongler, they release a much higher volume.
Does it come out at a higher flow rate?
Let me check. It does. I don't know. What you want the mass flow rate of chimp ejaculation?
I'm curious if chimps.
No.
I'm curious if chimps going a different way.
Why do you like that phrase?
Because it's insane. Maybe that'll get us to Navier-Stokes.
Wow, no one is going to understand what you just said.
That's okay. That's what the podcast is for.
But I do.
That's what the podcast is for.
I mean, it's probably turbulent.
Welcome to the Office Hours.
We're talking about flow. Welcome to Office Hours, the brand new version of Office Hours, where myself, my state-appointed ward, ADEF, and of course, FCC on the boards, joins you each and every week, taking your questions from Patreon only. If you want your question featured on Office Hours, go to patreon.com/Kyle Hill. Some of these videos may go up on YouTube as well simultaneously, but if you want your question answered, the only place you can have it answered is on Patreon. And it also has an added option where you can download the audio separately and put it has its own Patreon RSS audio feed. So you can load this into any podcatcher that you want.
This first question says, why did chimps go a different way?
Yes. Okay. I've been preparing for this one.
No. Okay.
So
I was thinking.
So you know the shape of your dongler, right?
No. I've never seen it. I close my eyes every time I go to the bathroom. I was thinking.
Can you look up the flow rate of the chimp?
No.
Okay. All right. That's fine. It's fine.
Chimp.
It's my
dong flow rate.
That is what you put in.
Monkey dong review. Okay. I was thinking lately, with expertise comes wisdom. Since you've been doing science communication for a long time,
it's true.
You've built a serious amount of expertise in this domain of explaining science to the masses. They're really buttering you up.
So, some would say.
Some would say. What would you say? What would you say are the most important things you've learned from doing this, both as it pertains to science communication and beyond? And what would be the most important piece of advice you have for researchers like me?
Yes. If I'm an expert in anything, I guess I've been doing this professionally for 13 years now, so I guess I have some semblance of knowing how to do some things. Good science communication is the art of taking the complicated and making it commonplace without losing the truth in between. That's what I say now.
Yeah, I wasn't going to congratulate you, but it is good.
Thank you. I was waiting for it.
It's a good little platitude.
Yes, thank you.
It's nice.
It's a good little platitude. Look at me. I can't even grow a beard.
Let's look up platitude on a remarkable.
Oh, it's a picture of me. Damn it. No. So that is the art of science communication. Science communication is just a variant of good communication. To young researchers or science enthusiasts who want to get into communicating science, I think beyond, of course, you need to have a pretty good grasp of what you're talking about, right? I think it was Feynman that said you can't truly, once you can teach something, then you truly
know it.
You truly understand it. So, having a good grasp of your field or what you want to communicate is always important. And even though I'm not an expert in most of the things I talk about on the channel and here, I try to do enough conceptual understanding beforehand so I feel confident enough, at least in the basics of what I'm saying. So you need to know what you're talking about to an extent. The other thing is that people can smell inauthenticity a mile away.
Sure.
And if it sounds like you're reading a script, if it sounds like someone wrote something for you, people are going to immediately identify that. And so harnessing your own voice and your own enthusiasm is critical. But then if you actually want to get into communication professionally, and you've done this, I've done this, it's really about finding that niche. Find what you want to talk about and make it your own thing. You've done this with...
That's the best piece of advice you gave me, I think.
You've done this with Pokemon videos and science and math and physics videos very, very well. Everything that I make, everything is intentional. When we're inside the walls of the facility, I'm more silly and upbeat, and my voice will sound different, and how I speak is different, and I'll show fun visuals and stuff like that. But for the Half-Life History series, it is an intentional shift to be a lot more measured, to read off of an essay that I had written, to be more somber if it calls for it. You can make everything in your communication intentional. So think about every aspect of what you're doing. The smartest person in the world can be really boring.
Yeah.
You need to think about phrasing, pacing, context, how you look, how you sound, on what platform you're on, how often are you talking about things, what are you talking, so there's a lot of thinking that goes into it, but I would think, as Adef mentioned, what is the thing you really want to focus on, and how can you make it your own?
Yeah, I would say there is some Venn diagram between like good performer and good science understander that like is the beautiful like married region where a great science communicator is. And I think both of those skills can be learned. And then at the end of the day, it really is. The best piece of advice you gave me is a dissemination of what you just said, which is like, you have to figure out what you can do that nobody else can do. Like, what's your niche or spin on this that no one else is doing?
Why listen to you as opposed to the 20 other people who are doing the same thing?
Yeah,
right.
100%.
Yeah.
Hello, Kyle.
Hey.
Do you think we will reach a limit to researching nuclear energy? Just like Moore's law predicts that transistors can be miniaturized up to a certain extent before quantum tunneling takes effect, do you think that something similar would happen to nuclear energy such that we may no longer proceed further?
If anything...
Opposite?
If anything, not for a while, because it's... around the world, we started making the first reactors 70 years ago now, and from that point, we haven't even gotten to where... I'll put it this way. There's 4 generations of nuclear technology, and we've gotten through almost 3 of them, and we haven't gotten to the 4th generation of technology in decades. We are not at these advanced reactor technologies like you're hearing about now, and a lot of it is because of the suppression of building these technologies and bringing them to market and having things planned out and having people assume risk and et cetera, et cetera. So I don't think we're really anywhere close to basically solving this problem, because at least in the United States, we are 10 years behind what China's doing, and China's not figured everything out yet either. So there's going to be a long period of time before we have the ultimate in fission technology, and that's not to say anything about fusion technology, which we don't even have yet. So there's still a lot of work ahead of us, I think.
Yeah, I think a very short answer would be definitely not within our lifetime.
Well, mine.
Hi. Is
Hey!
how this one starts. listen.
I am not going to make it.
I have some thoughts on this one. Actually, this is an interesting one. What are some ways I can improve my academic/scientific journal or paper comprehension?
Yeah, so this one is a hard one because while there are general things I could say and that ADEF is going to say, honestly, scientific papers are not meant to be read by the public.
No, not at all.
And I don't mean you can't and you're not allowed to. What I mean is they are not written for you. Scientific papers are written to be read by experts in a very specific domain. And so when you encounter a paper, it's like, wow, I don't understand any of the acronyms here. It's like, yeah, it's not for you, Jen. The papers aren't for you. There's something to it. Well, there's a trend that has been happening that I like a lot, where a lot of papers are producing graphical abstracts that instead of like a big paragraph, they do basically a visual aid version of what the study says. And those are very easy to understand, and I like that trend. But since scientific papers aren't meant for you, the layperson, to read, it can be hard to get into them. That being said, the abstract will, in any scientific paper, you open it up online, the abstract will be the first thing that you see, and that will give you the goal, the methods, and the results of the entire study. As a general person, you probably don't need to go much further than that.
Yeah.
But there are things that you can do if you want to go further. It's like, okay, well, this is one study. That might not say the consensus view of what is happening in that field. So then you start searching for systematic reviews of studies or meta-analyses of studies. Those are studies of studies. And those studies will have an abstract that says, we looked at 1,000 papers all at once, and the majority of them said XYZ. That is a force multiplier in your research process. Search for systematic reviews and meta-analyses. Those are papers of papers of papers, and they will give you a clearer view of the consensus on some topic. I think I would start there before getting into like looking for sample size differences and et cetera, and conflicts of interest and blah, 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 you know.
Yeah, it's tough, right? Because like the purpose of a paper is not to communicate science to the masses.
No.
The purpose of the paper is to communicate with other experts in the field.
Yeah.
Like you said, like if I'm writing a paper on some high dimensionality magnetohydrodynamics,
like you do,
I don't want to have to write 10 pages to explain to you what a tensor is before I communicate that, because I'm going to assume anyone that's reading this paper already knows how to work with high dimensional tensors.
Yeah. And it gets to the point where it's like it's very niche. It's not meant for you. It's like,
right.
I read what ADEF et al. Said, and my paper is going to refute that. Now, it assumes you know everything that ADEF has ever done.
Yes, if I reference a different prominent research paper, I assume you've read it.
And that you understand it, and then you know it, so...
Yeah. I actually have an opinion on this, though, which is that I think, and these graphical abstracts sound great as a sort of, child of this, but I really believe that it would be nice if when people publish prominent or even non-prominent research papers, they don't know how they're going to do, they should publish the abstract that makes sense, that is the common type of abstract everybody publishes, and they should publish an abstract that is organized in such a way that it is digestible by somebody who doesn't know what a p-adic number is.
Yeah, well, I think these are what these graphical abstracts are. I'll show you some.
Yeah.
I mean, they're very good examples of, especially when you have a paper published in Science or Cell or Nature, like the big journals.
Right.
That's helpful. But I mean, to be honest, going to the primary research yourself without understanding the field is not where I would start.
There's a world where this may be, and I am not a big fan of AI, let it be said. But this might be something ChatGPT could do well.
Oh, no.
Definitely.
If
you take an abstract and copy and paste in ChatGPT and you're like, can you just dumb this down?
Summarize
5%?
this. No, that's one of the good use cases for something like this. Someone just told me, I haven't tried it yet, but Google just run out something called Notebook or whatever, and basically you can give it any amount of training data, and then it will make like a mini LLM that will search and answer only within that data, which could be extremely useful if you're like, okay, if we're researching a Half-Life history,
sure, and
you put 10 papers in it, and it's like, hey, can you find me that part where they said this?
Oh, that's cool.
Or could you summarize this one paper, like how many instances of X radiation were there and what was the highest dose? And it would just, it wouldn't go to the internet at all. Just go from those 10 papers.
See, that
could be
feels like
that could be super useful.
Let's stop using AI to copy artists. Let's do that.
Dude, I had to search for some stock Adobe images yesterday, and I had to click no generative AI as a filter because 99% of it was just nonsense. I was looking for a picture of an insect, and instead of any real photo, they just generated photos of the insect. It's like, well, I don't want that. That's the story of AI right now, though. I don't want that.
I don't want that.
Oh, well, too bad. Too bad.
When the continents were shifting around millions of years ago, how prevalent were earthquakes?
I don't, off the top of my head, I don't know. I disagree with the premise, giving that. No, let Chompy do it.
I can do it too.
I disagree with the premise in that the continental plates are still drifting.
They're
still drifting. They still shifting. As long as the Earth is alive, so to speak, it has a molten core. Everything on top of that molten, on top of the core and the mantle, all of these plates are still going to be shifting around. It's like when you get to a certain size of object in space, that object tends to spherify itself because that is the minimum surface area that you can have in 3 dimensions is a sphere. And so when you get enough gravity, the force of gravity overcomes the material strength of the object, and the material becomes more like a fluid. And so large planets are much more fluid than you imagine. It's not like a big rock it's more malleable. That's why the Earth is actually shaped in such a way that you can see how it spins, because it's fatter at the equator, because it's spinning, because it's not a hard rock. It's getting elongated into an oblate spheroid, I believe it's called.
That is what it is.
So all this is to say, continental plates, the things that you're sitting on right now, they still are moving around on top of this semi-fluid, more fluid kind of thing. So they're still going to be moving. They're moving right now. It's just very, very slowly at a rate that you can't feel or see.
It's like 10 millimeters or centimeters a year.
Yeah, it's like I think it's
the fastest moving one is somewhere in Australia, and it's like 10 millimeters or 10. There's a Map Men episode about this,
I think it's as quick. Chompy, can you check me on this? I think it's as quick. Don't let her do it. Let her do it. Don't you get off that?
I'm not touching.
I think it's about as quick as your fingernails grow, is how fast the continents move. Can we double check that? I think that's the comparison that communicators have used.
1.5 to 10 centimeters per year.
10 centimeters a year. See, that's what I said.
Okay, that's definitely not your fingernails.
10 centimeters a year.
Per year, yeah.
Oh,
or half, 0.6 to 4 inches per year.
Was that close to how fast your fingernails grow?
How fast do your fingernails grow in a year?
Her do her job.
It's about the same. It's somewhere in the same
ballpark.
I think it's the same order of magnitude.
My fingernails each year either grow 5 inches or 50. I don't know.
I meant on the order of 10 to the 0. We're talking one.
Fingernails grow about 1.5 inches per year on average.
Okay, so that's within the same order. It's within a factor of 2.
It's within a factor of 10, I think. Or yes, I understand what you're saying.
Order of magnitude specifically is factor of 10.
Yes, I understand that.
Dang it.
So,
what was the second part of that question?
I think it was just how prevalent were earthquakes. I think know. The short answer is we probably don't know definitively, but probably pretty prevalent.
I think
the whole thing was an earthquake.
The whole thing was an earthquake. I think, Chompy, back me up on this. Check this out. I think early Earth was much more geologically active.
Yes.
When it was in its formation phase, when it was in heavy bombardment phase, when it was getting hit by debris from space, I believe it would. There's magma oceans, there's volcanoes. It was probably much more geologically active than it is now, and probably more earthquakes.
Volcanoes and mountains were rising and falling much more commonly in that era.
Yeah, it's saying that most earthquakes now happen on the edges of the plates, but before it was like there's way more stress from different places, so there's a lot more widespread earthquakes.
Well, there you go. That's FCC for you.
That's Fact Checker Chompy.
I'm doing my part.
This one says, okay, I'll ask.
Okay.
I'll ask, since the papers...
That sounds like... does anyone have any reason why these two shouldn't be wed? And you're like, All right.
I mean,
Do
nobody's.
I have to say it?
Yeah, I'll do it.
Do I have to say it? All right. Okay.
I'll ask, since the papers or news outlets nowadays, I guess, are farming clicks from it. So they're recalling radioactive shrimp.
I have a short going. You've probably already seen a short go out about this.
So they did surgery on a grape. So they're recalling radioactive shrimp. But how bad could it really be?
I mean,
and is the press response, as usual, overblown, even if the big bad is the featured player, cesium-137, in more than one Half-Life history?
Yeah, that's true. So cesium-137 is famously, it is the main contaminant in the Chernobyl and Fukushima exclusion zones. That's because it has a long half-life of about 30 years. So it's only gone through about one half-life in Chernobyl. It's not even close to one half-life yet, since that was 2011 in Fukushima. So it's still a half of a half-life at this point. So it sticks around for a long time as a fission product. It comes out of a nuclear meltdown because as fission reactions happen, one of the fission products is cesium-137. So if you have all that melting down, that cesium-137 can boil out and then fall out somewhere else. And then it sticks around for a long time as opposed to other isotopes that have shorter half-lives. So you can find it in nuclear contamination zones. But we also it's also a normal byproduct of nuclear reactions. In a nuclear reactor, we find cesium. But we also use cesium-137 for therapeutic purposes in cancer treatment, medical diagnostic treatment, that kind of thing, because it's a pretty radioactive source, because the half-life, relatively speaking, is so small in comparison to something like uranium-238, which I think is like hundreds of millions or billions of years. So it decays much more slowly. We also use cesium-137 for food irradiation.
Now, Kyle,
hey guys, did you know that we irradiate our food?
Why would I want to irradiate my shrimps?
Because you're not putting any radioactive stuff in the shrimp. You're using radiation to kill all the bacteria and microorganisms on the shrimp. And so you can sterilize medical equipment, food, anything else. I mean, you've heard of sterilizing surfaces with UV, right? You heard about that, Jumpy?
You heard of You guys see this? You hear about this?
Hear about this? That's ultraviolet radiation. That's radiation. And so if you have a more powerful form of radiation, you can get better sterilization. That's what you use cesium-137 for. Now, I already said this in the short that we made, and this will probably come out after that. So if I had to guess where any contamination would come from, it would probably be if we're using cesium somewhere in Indonesia to irradiate food for sterilization. Maybe some part of that made it into some part of the process and contaminated the shrimp. I don't know. Or maybe, no, I don't know. I can't speculate. I don't want to speculate. So, but we use cesium in more places than just contaminated places. And so it could be from one of those other places. Or the shrimp was rolling around in Chernobyl. And they went,
yeah,
I think I'll have that.
They were trying to have a Teenage Mutant Ninja Turtles situation.
What flavor of goo made those turtles into teenagers?
Was it radioactive or was it just goo?
I don't know. And also, being the nerd that I am, either someone else wrote this or I looked it up. It was either me or some other guy. But there's a way to determine the age of a turt by like how many, what their shell looks like. And in all the versions of the Ninja Turtles, they don't have enough of those features on their shells to be actually teenaged.
Oh, isn't
that stupid?
An incredibly...
The turtles were exposed to the ooze.
What's in the ooze, Chumpy?
Mutagen.
Okay, so that's not necessarily radioactivity. Radioactivity can be a mutagen, something that causes mutations. But it can also be chemicals, like the stuff in cigarettes.
It originated in the Dimension X and was brought to Earth by the alien Krang.
Oh. See, now that was a good fact check there, Chuck.
Do you guys know chimps went another way?
They did. So instead of... Wait, is this also a fact? Are chimps' testicles above their schwanger?
I'm not looking it up.
Look it up.
No.
I'll do it.
I think they also have a setup so it's not a wanger on top and testicles on bottom. I think their testicles go over on top of the wang.
I don't need to know all that.
Don't you? How else would you know how they get it in there?
This says why humans are less well endowed than chimps. So it sounds like they didn't go another way. I can't. We got to go to the next question. We got to go to the next question.
Wait, but then the whole beginning of the episode's gonna be wrong. No, chimps got small wangs.
All right. I'm going incognito browser. Do chimps have
Chimpy, can you look this up?
small penises? Okay, but AI is always going to say yes.
Why? What? See, there you go.
This is on theconversation.com.
The conversation is where researchers post for the general public.
What an insane thumbnail.
I like that. It is a picture of a banana coming out of boxer shorts with a ruler next to it.
Good.
A chimpanzee's testes weigh more than a third of its brain, while ours weigh in at less than 3%.
Yes, a third. That's 10 times. A chimp's testes, dear chat, is 10 times the average weight of human testes.
Compared to the size of their brain.
Yes. But they also said compared to the size of our brains too, so I'm comparing the two, it's the same.
Our testes are 3% the size of our brains.
Oh, but
their testes
are larger.
Their testes are 33% of their brains.
Yeah, it's so that's so much bigger than I thought. So they have much larger testes, but much smaller gawingas.
Yes, they're gawingas.
But are their testicles above their wiener?
So what will your next commander deck be that you're going to build? Anything piquing your interest in the Avatar or Spider-Man set?
First of all, there's too many Magic the Gathering sets. I can't keep track of it. And even me, I have tens of thousands of Magic cards, and there's too many coming out. I can't keep track. It annoys me. To answer your question quickly, the next commander deck I'm probably going to build is one of three. The Hearth Hull from Edge of Eternities, a Land Matters deck in Jund, or I'm going to build Y'shtola from the Final Fantasy set, or I'm going to build Rowan, Sign of War, or I'm going to build all three of them. I'll probably build all three of them and buy cards.
I have an answer to this one that's quick and easy.
Oh, it's your show.
Chimps went the other way. You've been handed a big paintbrush.
Can you look up if the testicles go above? I think...
Do chimpanzees...
Or is that kangaroos?
Go above their schwangs.
Thank you. Look up a photo, too.
No, it appears... Look up a photo? Okay. Those nuts are below that dingle.
Yeah, but look how big they are.
They are huge.
Okay, so I have that wrong. But they have testicles that weigh 30.
Jesus Christ.
That's their brain. And that's a wang. Oh, my goodness.
Red pill, blue pill.
I don't know. That's a hard choice there.
Okay.
I'm staying in the Matrix.
You have been handed a big paintbrush and paint bucket full of a substance that, when it dries, makes something frictionless. What is the first thing you would paint? So I made a video about this. Kind of.
Well, let me give my... So you know more than me. So I'll let you answer this.
Sure.
But the only thing that I know that's frictionless is low temperature helium, where if you super cool helium down to cryogenic temperatures like below 185 C? Yeah, like negative 300, 400 F, something like that. It loses all viscosity. And you can have a flask of helium, and if it's super cooled, because it has no friction, but it still has adhesion, cohesion and shit, it will climb out of the vessel against gravity and keep flowing.
Wow.
It's really weird. It's really cool. You should look that up. But for an expert answer.
So I made a video about how ice puzzles in Pokemon are frictionless because when you slide on them, you slide until you hit something.
Mm-hmm.
That video didn't go over so great because I put the wrong labels and said the wrong labels for a Newton's third law pair on a free body diagram, and a guy basically told me to kill myself.
You fool!
That was cool. But within that video, I said that I think one of the best applications if you had frictionless technology would be to frictionless coat turbines. So like if you have a power generating apparatus and you can start generating power, because basically all power generating apparatus are turning a turbine.
Well, you would increase the efficiency of that power production by a lot.
Well, once you start turning it, in essence, it's lossless.
Well, if you can make things truly frictionless with no additional energy input,
you're violating a lot of the laws of thermodynamics.
then you have a perpetual motion device.
Yes.
Which can't be actually done because even to make the helium with zero viscosity, you still have to
generate energy.
Put in the energy to cool it down.
And you're going to lose stuff to maybe sound or air.
No. But think of what you could do. Yeah, I mean, there will still be air resistance, but imagine if you could have Pokemon-style frictionless travel between two locations.
That was the other thing I said was...
You could just push a car.
Yes, exactly.
And it will just reach the other location, and now you have, like, a traffic system based on, like...
That's exactly what I said.
A traffic system based on, like, the lifts at a ski hill or something like that. It's like, okay, get on, and it will just...
Yeah, it's like when you get on a water slide and there's like the green light, you're like, now you can go.
Yeah, and
I did a bit where I was like, oh, honey, hang on, I'll be there in a couple hours. I have to get on the ice superhighway.
Yeah, just
that's easy.
Frictionless travel. I mean, and space isn't even truly frictionless, but you can do the same thing. Where if you don't encounter another field, you will travel in a straight line at the same velocity forever, and that's why space travel can do the cool things that it does. Where you don't have to thrust the entire way. You can thrust into orbit, and then you have to correct yourself a little bit here and there. But once you're in orbit, you just go.
When is the GDQ collab?
You tell me.
Whenever you want. Come back to the main event. We'll get you on camera.
So if you don't know, 8F works at GDQ, Games Done Quick, which is, I believe, at least for Prevent Cancer Foundation? No, the Doctors Without Borders.
Well, AGDQ is for Prevent Cancer. Summer Games Done Quick is Médecins Sans Frontières. Yeah.
For Médecins Sans Frontières, that was terrible. You speak French.
I do.
You say it better.
Médecins Sans Frontières.
Wow. I went to college.
I did.
I think GDQ, which you should check out, it happens twice a year, the big ones, and consistently every day on Twitch, pretty much. It is the single largest donation source for Doctors Without Borders ever. I think that's true.
I don't know that for a fact, but I know we have raised literally tens of millions of dollars.
So all that is to say, it's a great cause. It is a great event. 8F works there. He does great hosting gigs. I love the little science time that they gave you a couple GDQs ago.
That might be coming back.
Yeah, no, that was great. I'd love to come out and do something. I don't speed run anything, but I could be entertaining.
I haven't really.
We could do this there.
I mean, unironically.
You heard it here first. It's coming to you quick. Thank you. I saw your little finger going towards it.
Chompy's got the button. Yay!
Another successful episode. Any closing thoughts?
Chimps chose they went a different way.
They did. So not as... Thank you so much for joining us this episode of Office Hours. Of course, if you want your question... I'm afraid we're going to get a lot of chimp questions next time. But if you want your question answered, the only way to do so is to join the Patreon, patreon.com/Kyle Hill. That's where we'll be pulling questions from. You may see this, you may be listening to this on your podcatcher, may see this on YouTube, but most of the episodes will be on Patreon, and they'll be free for patrons, and that's who I'll be pulling questions from. And